In this lecture, we will solve the numerical on the determination of main dimensions of a synchronous machine. Now, the example which we are going to solve in this lecture is find the main dimensions of a 100 MVA, 11 kV, 50 Hertz, 4 pole, 40 pole salient pole generator. Assume specific magnetic loading 0.65 Weber per meter square, specific electric loading 40,000 ampere conductor per meter. The peripheral speed should not exceed the 60 meter per second. Now, if you read this example, then the given data is MVA is 100 MVA. So, if the MVA is 100 MVA, then the kVA returns becomes the 100 into 1000. So, MVA is given, means we can write the kVA as 100 into 1000. 50 Hertz is the frequency. Number of poles are 40. And the specific magnetic loading BAV is 0.65. Specific electric loading AC is 40,000. And the peripheral speed should not be exceed 60 meter per second. It means the peripheral speed is given 60 meter per second. Also, if we calculate the synchronous speed at the 40 number of poles and the 50 Hertz frequency by using the expression Ns is equals to 120 F by P. So, from this equation at 50 Hertz frequency and 40 number of poles, the synchronous speed becomes 150 RPM. So, Ns is 150 RPM. And we need to calculate here the main dimensions, that is D and L, and we will calculate these main dimensions D and L from the output equation. As we know that the output equation of a synchronous machine is the same as the induction motor, so the D square L is equals to kVA divided by CO into Ns, where the CO is 1.11 kW BAV into AC into pi square into 10 to the power minus 3. So, first we will calculate the CO and kVA along with the Ns, and then we will insert these values in the expression of the D square L, and we will calculate the product D square L. So, while calculating the output coefficient CO, in this example, the winding factor Kw is not given. So, for that purpose, let me assume the full pitched winding, and for the full pitched winding, the winding factor is 0.955. So, if we insert other given data in the expression of the CO, then it becomes CO is equals to 1.11 into 0.955, that is Kw, into 0.65, that is BAV, into 40,000, that is AC, into pi square into 10 to the power minus 3, and after the calculations we will get 272.0.19. So, the value of the CO is 272.019. Other parameter which we require to calculate the D square L is the kVA, and the kVA is directly given in this example, that is 100 into 1000. So, let me calculate the value of the Ns, and that Ns is equals to, here the capital Ns is given 150 RPM. So, the small Ns is 150 divided by 60, that is 2.5 RPS. So, therefore, if we put these values in the D square L equation, then the D square L equation becomes 100 into 1000, that is kVA, divided by 272.019, which is the output coefficient CO, which we have already calculated in the previous step. So this is the value of the CO into the ns. Ns is equals to 2.5 revolutions per second, and after calculating this we will get 147. Now, while calculation of the main dimensions in this example, the constraint is given, and that constraint is we need to calculate the main dimensions d and l so as the peripheral speed should not be exceed the 60 meter per second. So at the 60 meter per second peripheral speed, we need to calculate the main dimensions. So as we know that the peripheral speed v is equals to pi d into n. So from this equation we can calculate directly the value of the d. V is equals to pi d into ns. So as the v is 60 is given and ns is 2.5. So the only unknown is d, and that d is equals to 60 divided by pi into 2.5, and we will get after this calculation 7.7 7.639 meter. Now we will put this value of the d in the equation of the d square l. The equation d square l is equals to 147. So if you put in this equation, then the l becomes 147 divided by 7.639 square, and this becomes 2.51 meter. So we are getting answer very simply, the d equals to 7.639 meter and l is equals to 2.51 meter. So similar type of two examples are given in the exercise. This is example number 1 and this is the example number 2. So solve these two examples as a practice at home. Thanks for watching.